Hi, welcome to EC&M Tech Talk. In this episode today, we're going to talk about insulation resistance testing. EC&M Tech Talks is brought to you by EC&M Magazine, and it's a hands-on series of videos where we talk about everything from installation techniques to maintenance and everything in between, I suppose. So anyway, the content is handpicked by the editorial team here at EC&M, and it's designed to meet your needs as far as basic theory, technical topics on installation techniques from the NEC, maintenance of specific equipment, operation of specific equipment, and so on. So anyway, welcome. If you're interested in finding out more, and you may have already found it, but if you go to ecmweb.com, so ecmweb.com, and then you look in the upper left-hand corner, and there's a drop-down menu. Click on that drop-down menu, and the first thing that you see is called Premium Content. Click on Premium Content and go there. It's a members-only portion of the EC&M website, but you can easily join, no problem at all, and you'll find tons of information on all types of electrical topics. And of course, that's where you find our EC&M Tech Talk. So anyway, I'm Randy Barnett. I'm a journeyman electrician, electrical safety compliance professional, worked as an electrical inspector, and just a lot of mostly industrial commercial work over the years then. So anyway, let's get started on insulation resistance testing. And let's just begin maybe with what is insulation resistance testing? What does it do and why do we do it and so on? First of all, here's a piece of 2 AWG copper with THHN insulation on it. And so the insulation, as we discussed in our last episode, is THHN is rated for 90 degrees C. If I start to overheat that insulation, it can break down. Or maybe when I pull, especially if I have several of these suckers, and I'm pulling them into a conduit, into a raceway, it's easy to nick a little bit of insulation off. And of course, if it's, 143 feet down the raceway, I'm not going to know about that. And so the NEC, we're going to find out, requires us to make sure that doesn't happen. And we'll see how we can comply with that. And it's through insulation resistance testing then. So the purpose of insulation is to keep, as I say, to keep the electrons in the wire. Okay, the purpose of the insulation is to keep the electrons, the electricity in the copper. We don't want any of those electrons to leak out. Let's say if I run this conductor through some metal raceway, like some rigid conduit, and something happens and I do nick some insulation off, and now the current flows from the copper through the missing insulation, right, or the cracked insulation, whatever it is, and now flows into the metal raceway. That's called a ground fault. Current may or may not have flowed into the ground. A ground fault is when current flows into the normally non-current carrying metal components of my system. Now, I don't want that for two reasons. Number one is first of all, if I have a raceway or metal enclosure or whatever it is that becomes energized, somebody could get shocked, or even worse, something terrible could happen. Not to mention what? I could cause excessive heat and cause a fire. So I certainly don't want either of those to happen. That would violate the purpose of my NEC, wouldn't it? So the three big killers on this insulation: heat, dirt, and moisture. Okay? So heat, if I overheat the insulation, it tends to break down. Dirt and moisture can find its way into cracks and deteriorating insulation, and then give a low resistance path for current to flow into metal enclosures and so on. So I don't want that to happen. So we need to take a look at, first of all, let's talk about 110.7. I'm going to go on my NEC. So I've got my 2020 National Electrical Code, well, most current edition. And I'm going to go to section 110.7. Okay? It's in Article 110, which is requirements for electrical installations. And let me just read 110.7 to you. 110.7, wiring integrity. Completed wiring installations shall be free from short circuits, ground faults, or any connections to ground other than as required or permitted elsewhere in this code. So right there, I installed wiring in a raceway. It has to be free of ground faults. That's a requirement. It's a requirement of 110.7 in the NEC. How do I verify it's free of ground faults? And the answer is Well, you probably wouldn't unless you ran some kind of test on it. You wouldn't know. So you have to run a test. And what is the test that you run? It's an insulation resistance test. Also, in the world of troubleshooting, lots of times on motors, we run into issues on motors, don't we? Oh, we have a motor that fails. And so one of the first tests we're probably going to run to see what happened, see if the insulation broke down in the motor, we'll run an insulation resistance test. And also, it's a part of our general maintenance activities on motors we'll talk about as well. So lots of reasons, good reasons to run insulation resistance tests. Any electrical equipment, motors, cables, wiring in raceways, transformers, all of my electrical equipment, I need to think about insulation on it. So let's talk about how we're going to run an insulation resistance test. Now, first of all, the way not to do it. And by the way, I have my rubber gloves, I actually have 2 meters here. Everything's been inspected before use, and I've got my safety glasses on. But what I see a lot of people do is they'll go ahead and they'll take and turn their multimeter, their nice digital multimeter, onto this resistance scale, which is fine, right? And if I touch my 2 test leads together, so right now the meter is reading open line, open circuit. I have electrons, let's say, that have flowed out to the black test lead from the battery inside the meter. They would love to get over to the red test lead, but they can't do it right now because I have open line or open leads. But if I take and I touch these 2 test leads together, what happens on the face of my meter? It looks like it's reading about, I don't know, bouncing around about 0.2 ohms, something like that. So now my electrons can flow into the red test lead, back into the meter, back into the data portion of the meter, where the amount of the current that's actually flowing back into the meter is calibrated to read out in ohms of resistance. Typically, when we do these insulation resistance tests, we're worried about the millions of ohms of resistance. We want to make sure that we want to meet some minimum value for millions of ohms of resistance, or what we call mega ohms. Okay, so mega ohms of resistance is a common term. So what I'll see people do is they'll say, oh, well, the motor failed. There was some smoke coming out of the motor, so I'm going to go ahead and test the insulation resistance on this motor. So what I'll do is I set my meter up to read resistance, and I take 1 test lead and I put up here on a good ground, say on the black, on the metal casing where there is no paint, and then I touch one of the phases. And I read, oh, open circuit. Wow, open circuit on all 3 phases. Wow, open circuit on all 3 phases. That's great. An infinite amount of resistance. The problem is this meter right now is only putting out somewhere around, I don't know, you can measure it, but around 2, 3, 4 volts, something like that. That's kind of like, like if I built a hydraulic system, right? So let's say that I am a great hydraulics engineer. Not, okay? But anyway, and I build this hydraulic system. I got valves and pumps and, of course, lots of piping, accumulators and all this kinds of stuff. And I'm going to energize that hydraulic system to 1,500 psi, 1,500 pounds of pressure. So, being a smart guy, right, I'm going to go ahead and test that hydraulic system, make sure there aren't any leaks in it or somebody doesn't get hurt at 1,500 psi. So I'm going to go ahead and test it. So I'm going to hook up some test fittings to the piping over here, and I'm going to go to a little pump over here, and then I'm going to charge up my hydraulic system to 25 psi, 25 pounds of pressure. I didn't get any leaks in my hydraulic system. Great, I did a great job. Then I'm going to turn around, pull that fitting off, start my hydraulic pump, and now put 1,500 psi on that piping system. That'd be crazy. I want to test it at least whatever my pressure is going to be, probably something greater than that. The same is true with electrical circuits. This motor is rated for what? It says 440 to 460 volts. Okay, so this motor is rated up to 460 volts AC. Why would I want to test it with an electromotive force of 2 volts? 2 volts of electrical pressure, if you will, in order to see if the insulation breaks down, and then turn around and energize it to 460 volts. That wouldn't make much sense, would it? The insulation that looks great with my multimeter may certainly fail when I do an insulation resistance test on it, because to do the insulation resistance test, I'm going to use a meter something like this. This particular meter, it's got a selector switch on it, and I can choose 250 volts, 500 volts, or 1,000 volts output out of the meter. That's pretty good then. Okay? Now, and what voltage should I test my insulation at? Well, I don't want to go too high, because if I go too high, I can actually damage the insulation. In this spot reading test that we're going to do here in a second, the spot reading test is a non-destructive test, okay? It's a quick test that we can do to verify the condition of our insulation. And actually in a motor, if you've ever looked inside of a motor, and you can see the copper windings underneath that clear varnish usually, can't you? So it's a pretty thin insulation, and it's pretty hard if you try and scratch it or something. It's pretty tough insulation. So what happens to that insulation on those windings? Over time, it heats up, it cools down. It heats up when the motor runs, it cools down. It heats up, it cools down. And over time, that insulation begins to deteriorate. And what does my motor do? My motor vibrates as it's operating, right, just by its very nature. Maybe not that much, but it vibrates, doesn't it? Okay? And so that vibration, I tend to get cracks in that embrittled insulation. Dirt, moisture, over time, definitely accumulates inside of a motor. You know that if you've ever done motor maintenance. And so now, dirt, moisture works its way into those little cracks, and I've got a good path of current flow from the copper windings right out into the metal frame of the motor. I can watch that happen over time, by the way, right? I can not only do a test today to determine if this motor is good or bad, but I can also watch it over time, that insulation break down. So let's say today if I ran my test and I had, 100 mega ohms of resistance. I come back in 6 months and it's 60 mega ohms of resistance. And I come back every 6 months or whatever my schedule is, and I can watch and I can actually plot out and watch that insulation breaking down over time, 60, 50, 40, 30 over the years, whatever. And I can predict maybe even when it's going to fail. What is the minimum resistance I should see in a motor? Well, depends. Always consult manufacturer's instructions, but let me show you something else that exists that should be of good benefit to you in this insulation resistance testing. This is the NFPA 70B recommended practice on electrical equipment maintenance. And let me give you a heads up. This is going to become a standard in its next edition. So that means it's going to go from, this is a recommended way that we think you should maintain your electrical equipment, to this will be the standard for maintaining your electrical equipment. And it talks about insulation resistance testing. So, what does it say about motors? Well, I'm going to go to Chapter 11. So Chapter 11, which a lot of stuff in here, but anyway, Chapter 11, Table 11.20.1.2, rotating machine insulation testing. You probably got that memorized, right? Okay. Let's see, Table 11.20.1.2, rotating machinery voltage, 1,000 volts and below. The insulation resistance minimum has to be at least 2 mega ohms. 2 million ohms of resistance when I run this test that I'm going to do in just a minute. If it's less than 2 mega ohms of resistance, my motor has failed. So to be honest with you, if I actually ran this test today and I get anywhere close to 2 mega ohms, actually for me, if I start getting down around 5 mega ohms, I'm getting worried about this motor. It's getting ready to fail. I better have a spare one on hand or think about replacing this one and get it rewound, or a little guy like this would just replace, wouldn't we? So anyway, let's do an insulation resistance test then. So to do the insulation resistance test, I'm going to select 500 volts on my ohm meter because this motor has been in service and I don't want to exceed the insulation resistance rating on the motor. So I'm going to choose 500 volts. I could go up to 1,000, especially if it were a new motor. I'm going to go ahead and put on my rubber gloves. I've got my safety glasses on. And I'm going to take one test lead. I'll take the black test lead and I'll clip it on to ground. And then I have the red test lead. And this works the same way as I just explained to you on the ohm meter, in that the current leaves one test lead, travels out, flows into the windings. If there's any breakdown in the windings, the current would flow through the cracks or whatever in the windings, wherever it's melted or whatever, and that current would then flow into the metal frame of the motor, and the amount of current that flows back into my mega ohm meter, we call this in this case, because it reads out in millions of ohms, the amount of current that flows back in is calibrated to read in mega ohms of resistance. Right? So let's see what we get. I'm going to go ahead and make sure I'm set up. I'm going to turn it to 500 volts. Okay, so now when I push the test push button, it reads 504 volts up on the top, 505. So it's putting out 505 volts. The larger numbers down below is my resistance readings. And you saw it bounce around a little bit, and then it went back to 1. 1 indicates infinity, meaning that the insulation resistance between the windings and the frame of this motor has exceeded the value that this meter can read. So it's reading infinite resistance, which is great. The higher the resistance reading, the better. Okay? And so then I can try it on B phase. There we are, 504 volts again. Oh, do you see it bounce around on the bottom? It went to look like 616. Couldn't even catch if it was mega ohms or not. And then it goes back to infinity. That's not the meter's fault. What you're seeing is, you're seeing an inrush of current into that those motor windings. That inrush of current is doing a couple of different things. One is, some of it's going up to charge, create a capacitance between the windings and ground, and some of it is actually getting stored in the insulation, called dielectric absorption. So we will see those, initially when we take a reading, we will see that number bounce around a little bit. And that is those two different readings. I'll go over to A phase. Push it. There's our 500 volts. And went to 497 mega ohms or something. I couldn't tell, couldn't catch it. And then it's back to infinity again. So when that meter bounces around, you can really see it on an analog meter. I'm looking at capacitive charging current and dielectric absorption. Now, oh, by the way, my meter did go back to 0. One thing you have to keep in mind on safety on these is discharge. And so make sure we're back to 0 volts. The meter's been inspected before use, so I'm at 0 volts. Little motors like this, short runs of wire, will discharge themselves very quickly. Not true. Larger motors, transformers with lots of windings, long cable runs, they will stay charged for quite a while. The general rule of thumb is that we discharge a circuit for twice as long as we applied the charging current to it in order to fully discharge it. Then, of course, we verify it with our meter. Now, how long then should I run this test to begin with, the spot reading test? The general rule of thumb is 1 minute. So use 1 minute, and that way we're all consistent. Because if I take a reading, and by the way, the dielectric absorption, the capacitive current will continue to build over time the longer I leave this motor energized. Don't see it so much on a quarter horse motor like this, but certainly 500 horsepower, something like that, you're going to see it. So as those current continues to build, you're going to see changing values on your mega ohm meter. And so what you need to do is make sure that we're all taking the same reading, so we use 1 minute as the standard then, okay? That way we're always reading the same values. Also, it's a good idea to check the temperature on your motor. Check with your mega ohm meter manufacturer and see if you need to correct for temperature. The temperature of all of our temperature ratings are assuming that the insulation on the inside is at 40 degrees C. Well, probably isn't, okay? So the temperature of the insulation will change, the resistance of the insulation will change with temperature changes, and so correct for temperature if you need to, and there are charts that allow you to do that. So anyway, that is insulation resistance testing in a nutshell. That is the simplest test. If you want to learn more about polarization index and dielectric absorption ratio and high potential testing and all of these other types of insulation resistance tests, which are very valuable for troubleshooting, acceptance testing, and so forth, then go to the members portal on ECMweb.com and look under that members content, and you will find several good articles just recently, within the last few months, on insulation resistance testing then. Okay? So we are out of time. I am Randy Barnett then. Once again, I would like to thank you for listening in today to EC&M Tech Talk, brought to you by EC&M Magazine, which is a portfolio of the Endeavor business publications. We look forward to the next time, where next month we'll be talking about motor starters. We're going to look at the installation, operation, and maybe a little bit about the maintenance of motor starters in. So the main thing is, work safely, and we'll see you in the next episode of EC&M Tech Talks.